So in this video I want to talk about who needs to worry about earthquakes. Where are we going to run into them? What regions of the country need to be extra careful? Where do we need to design our buildings to deal with them? Well, what do you think? Where do we see earthquakes in the United States? Yeah, a good guess is California, right? Over in California we've got the San Andreas Fault and all sorts of other faults over there, and we've had some serious earthquakes in California and urban areas over the years. In 1906 there's a big one in San Francisco, 1972 one in San Fernando area, 1989 there's the earthquake up in the Bay Area, and 1994 a big one in Northridge and Los Angeles area. So we know that California has to deal with earthquakes, but what about other parts of the country? Take a look at this map I'm going to pull up. Okay, let me explain what's going on in this map. What we're showing here is the United States, and all the colors over here, they're indicating values of this thing that's called the PGA. It's not the Professional Golf Association. Okay, the PGA in this context stands for peak, ground, acceleration. Okay, peak ground acceleration, and the people that put together a map like this, they're earth scientists, okay, that study geology and seismicity. And what this map is showing are the ground accelerations that have a 2% chance of exceedance in 50 years. Okay, and that's just a probability of this type of acceleration happening. And we could plot different probabilities, but this happens to be the one that we use as a basis for design now. 2% of exceedance in 50 years. Well, as you look at the map, look at the spot where you live. Do you live out here in California, or are you somewhere in the middle somewhere? I live over here in Utah, and so if I look at Utah, yeah, it's not so bad all over here. We've got a lot of green and light brown. Green and light brown, that's like 10%, these are in units of G, I should say, units of gravitational acceleration. So here where I get 10% G, maybe 20% G. Ooh, but look right here. I actually happen to live right in this area that's red with actually a little bit of brown on it. Okay? And so when we're talking about red and brown, we're over here. These are big accelerations. Okay, so let's think about what it means. 1 G of lateral acceleration. Think about it this way. Whatever building you're in, or I'm in, okay, it was designed, okay, to carry its own weight, and the weight is a gravitational force. Okay, it's equal to the mass of the building times gravity. Okay, and that weight of the building, that's the force that the structure needs to support, 1G of vertical force. Okay, now when we're talking about 1G of horizontal force, that's like taking this building that I'm in and picking it up on its side. So now it's like hanging out in space like this. Okay, and we've got 1G of lateral acceleration, or lateral force. Okay, so that gives you a feel for how big of a force this is, and I can guarantee you the building I'm sitting in right now, I don't think would stand up under that kind of lateral force. So anyway, as we look around the country at the areas that have these really high potential for ground acceleration, as we'd expect, we've got a lot out here in California, and I'm going to have to be careful there. And then all along the west coast of the United States, you know, we've got this subduction zone up here that can trigger earthquakes that would impact like Portland and Seattle. Okay, so we've got this major zone here, we've got this zone here of fault systems around the Yellowstone National Park area in Wyoming, Idaho, Utah, Montana. Okay, and then maybe this is stuff you're not as familiar with. Out here in Missouri, we've got this thing called the New Madrid Fault Zone. In the early 1800s, there were huge earthquakes out there, and that's the basis for this hazard that shows up right here. We've got hazard out here in South Carolina, again based on a huge historical earthquake that happened out there. And we've got a little bit going on up here and at the very top. Okay, best places to live if you don't want to see an earthquake. Man, Florida, that's looking pretty safe. Texas along the Gulf here. Okay, and then things are pretty quiet all through here in the kind of the middle of the country. So hopefully that's interesting. Hopefully you've taken a look at where you live and seen what your hazard is. And then, you know, if you're in one of these hot spots, seismic design, it's going to be a big issue, and you'll need to come up with some sort of system in your building that'll be able to resist these ground accelerations that we might expect to see.